Given the matrix that appears on screen, minus 1, 2, 3, minus 2, 1, 1, 3, 1, 3, let's calculate the inverse of matrix A. To calculate the inverse matrix of A, we will use Gauss. Gauss consists of the following. We write a matrix by blocks, on which the first matrix is the one we want to calculate the inverse. Minus 1, 2, 3, minus 2, 1, 1, 3, 1, 3. And the second block is the identity. As matrix A is a matrix 3 by 3, we write the identity matrix 3 by 3. Now you have to use elemental transformations on the rows of the matrix, so that the identity matrix ends up in the first block. If this can be managed, matrix A will be reversible, and its inverse would be the matrix that will appear in the second block. If it's impossible, it's because matrix A is not reversible. Let's begin. And the first thing we are going to do is with this minus 1 make 0 underneath, in the minus 2 and the minus 3. Then, what number have we got to multiply the minus 1 to add minus 2 and obtain 0? Obviously, minus 2. Then minus 2 times the first row plus the second row. What number have we got to multiply the minus 1 to add it to the 3, so it gives us 0? It would be 3. 3 times the first row plus the third row. As the first row is the one that makes the zeros, we copy it. And now we have to multiply the first row times minus 2. Let's multiply the first row times minus 2. So, minus 1 times minus 2 equals 2. 2 times minus 2 minus 4. 3 times minus 2 minus 6. 1 times minus 2 negative 2. 0 times minus 2 0. And 0 times minus 2 0. Now we copy the second row underneath. Minus 2, 1, 1, 0, 1, 0. And we add 2 plus negative 2, 0, minus 4 plus 1, minus 3, minus 6 plus 1, minus 5, minus 2 plus 0, minus 2, 0 plus 1, 1, and 0 plus 0, 0. Now we copy the results of the addition in the new second row. 0, 0, minus 3, minus 5, minus 2, 1, 0. Now we do 3 times the first row plus the third row. 3 times minus 1, minus 3, 3 times 2, 6, 3 times 9, 3 times 3, 9, line 3 times 1, 3, 3 times 0, 0, 3 times 0, 0. And now we copy the third row. 3, 1, 3, 0, 0, 1. We add 0, 6 plus 1, 7, 9 plus 3, 12, 3 plus 0, 3, 0 plus 0, 0. And 0 plus 1, 1. Now we copy the results. 0, 7, 12, 3, 0, 1. And underneath this, negative 1 encounters a complication. Underneath this negative 3, you have to do 0. And what number have we got to multiply negative 3 so that the addition with 7 gives 0? In this equation, where the question is the variable, we have minus 3 times the question, and this 7, as it is adding, it goes to the other side subtracting. Question will be, minus 7 over minus 3. And as negative over negative is positive, we obtain 7 over 3. Now we multiply 7 over 3 times the second row plus the third row. And now apart, we erase this. So now we multiply 7/3 times the second row. 7/3 times 0, 0. 7/3 times negative 3, negative 7. 7/3 times negative 5, negative 35 over 3. Line 7/3 times negative 2, negative 14 over 3. 7/3 times 1, 7/3, and 7/3 times 0, 0. Now we copy a third row, 0, 7, 12, 3, 0, 1. And now we add 0 plus 0, 0, minus 7 plus 7, 0, minus 35 over 3 plus 12 equals 1/3, minus 14 over 3 plus 3 equals minus 5 over 3. 7 over 3 plus 0 equals 7 over 3. And 0 plus 1 equals 1. Now here, the first row, as it does not intervene, we copy it. The second row, as it is the one that makes the zeros, we copy it too. And the third row is here. We can observe that underneath the left matrix, the diagonal is made up of zeros. This means that the range of the matrix on the left, which is the same as the range of the matrix A, because you obtain it from the matrix A, doing elemental transformations, is 3. And from this we can deduce that the A matrix is reversible. Now we know that it is reversible. If we had obtained any row filled with zeros, the matrix A would have not been reversible. Let's continue. The first thing we are going to do now is multiply the last row times 3 so that we get rid of the fractions. We erase this. Multiply all the rows times 3. We copy the first one, negative 1, 2, 3, 1, 0, 0. The second one too, 0, negative 3, negative 5, negative 2, 1, 0. The third one gets multiplied times 3. 3 times 0 is 0, 3 times 0 is 0, 3 times 1/3 is 1, 3 times negative 5 over 3 is negative 5, 3 times 7 over 3 is 7, 3 times 1 is 3. Now with this 1 we have to make zeros on top. In this case, negative 5 and this 3. So, what number have we got to multiply 1 so that when we add it to negative 5 gives 0? Obviously 5. 5 times the third plus the second. Which number have we got to multiply 1 so that when we add it to 3 it gives 0? Obviously negative 3. So, negative 3 times third plus the first. The third row is the one that makes the zeros, so we copy it. 0, 0, 1, negative 5, 7, 3. Now, 5 times the third row. 5 times 0 is 0. 5 times 0 is 0. 5 times 1 is 1. 5 times negative 5, negative 25. Now, we are going to put here the line. 5 times 7 is 35. 5 times 3 is 15. Plus the second, 0, negative 3, negative 5, negative 2, 1, 0. Now we add. 0 plus 0 equals 0. 3 plus 0 equals negative 3. Negative 5 plus 5, 0. Negative 2 plus negative 25, negative 27. 1 plus 36, 1 plus 35, 36, and 0 plus 15, 15. Now we copy this in the second row, and we multiply -3 times the third row. -3 times 0, 0, -3 times 0, 0, -3 times 1, -3, -3 times -5, 15, -3 times 7, -21, and -3 times 3, -9. Now we copy the first. Okay, so now we add -1 plus 0, -1, 2 plus 0, 2, 3, negative 3 plus -3, 0, 1 plus 15, 16, 0 plus -21, -21, and 0 plus -9, -9. Now we copy the results of our operation. Now we erase the operation we have done before. Now that we have here on top a 0 and here 2, now we are going to do 0 with this -3 on top. One number has -3 to be multiplied by, so that added to 2 gives 0. -3 times the unknown parameter would give us -2. So the unknown parameter would be -2 over -3, which equals 2/3. Then we would do 2/3 times the second plus the first. As the third does not intervene with it, we copy it. The second, as it is the one making the zeros, we copy it. We always have to copy the one that makes the zeros. And now we copy 2/3 times the second plus the first. So 2/3 times 0, 0. 2/3 times -3, -2. 2/3 times 0, 0. 2/3 times -27, it's -18. 2/3 times 36 is 24. 2/3 times 15 is 10. Now we add the first. -1, 2, 0, 16, -21, -9. The answer to this operation would be -1, 0, 0, -2, 3, 1. So once we've done this, we copy the answer into the first row. Now we've almost finished, because we were seeking the identity matrix, but we got a diagonal matrix. So now all we have to do is multiply each row times its inverse. So that means we multiply the first row times -1 and the second row times -1/3. So the first row times -1 would be 1, 0, 0, 2, -3, -1. And the second row times -1/3 would be 0, 1, 0, 9, -12, and -5. Now what we do is we copy the third row. We have obtained the identity matrix in the first block. We knew that the matrix was reversible, and because of that we are going to be able to make it. Now all that remains is to write what the inverse matrix was or is. So the inverse matrix would be A minus 1 equals 2, negative 3, negative 1, 9, negative 12, negative 5, negative 5, 7, 3. It is convenient that every time you calculate the inverse matrix, you verify that it really is. To verify this, you only have to multiply the initial matrix times the inverse matrix, and it will give you the identity matrix. In this case, you don't have to verify it because we already have, and it is correct.